Welcome everybody. We're so happy to have you here at the Public AI Summit. Today is day one of 2 days that we've organized together between the Data Nutrition Project and the AI Pedagogy Project. I know folks are still coming in, but we're going to jump right in and with some introductions and then turn it over to our first keynote speaker, Arvind. So why are we here? Well, you all know why you're here because you registered, but really we wanted to get together to talk about understanding AI, what it means, where it's going, and how we shape it. And we're doing that today with three amazing keynote speakers. Arvind Narayanan is going to be the first one, and he'll be followed by Kathy Pham, Mahabali, and Anna Mills together. This event is co-organized between the Data Nutrition Project and the AI Pedagogy Project, and we're going to tell you a little bit about each. So I'll turn it over to Kasia to talk about DNP.
Hi, everyone. My name is Kasia Shimolinski. I am the executive director of the Data Nutrition Project. So DNP is focused on building better technical systems. We really focus on the data from the data up, right? So we began with creating nutrition labels for data sets, which is essentially, like a nutrition label like you'd have on food, but for a data set so you can see what's inside it before you use it. And since then, we've also started consulting with organizations around data governance and data quality. And we also do educational programming, such as this summit, alongside many amazing partners in the space, such as the AI Pedagogy Project. I will hand it back over to Newman.
Thanks, Kasia. So the AI Pedagogy Project is a project of MetaLab at Harvard, which is part of the Berkman Klein Center. And some of the organizers for this event, who I'll be introducing shortly, are also working with the AI Pedagogy Project in addition to working with Data Nutrition Project. And we started about 2 years ago with the goal of giving educators guidance for this difficult moment in education. We started with a focus on higher ed and really thinking about empowering folks, especially from the liberal arts, with how to think about AI, how to use AI tools responsibly, how to talk with their students about AI tools. A lot's happened in the last 2 years, but it's as relevant as ever for education. So we're so excited to be co-hosting this event across two different organizations, both of which are really focused on the responsible use of AI. This is the organizing team. I'm not going to call people out other than to say it's really a team effort. As of course you all can imagine, by having a big webinar is a lot of logistics, all the emails you got from us and the reminders and websites and organizing the speakers. And then for those of you who are joining us tomorrow, having 11 parallel workshops running, there's quite a bit of logistics. And so just really thrilled to thank Kasia, of course, here, and then Maria Dixis and Sebastian Rodriguez, who were instrumental in putting this all together. We also, the Data Nutrition Project is a nonprofit, and we have gotten support in the form of grants and gifts from New Media Ventures, Meta, and Microsoft that has helped support this summit. And then the AI Pedagogy Project is a project of MetaLab at Harvard and is supported by MetaLab. So it's really through a variety of types of support that this is possible, and we hope to do more of it. So what is happening today? I think you all know, I already alluded to it, but I wanted to give you the schedule too, because 3 hours is a pretty long stretch. So for people to just kind of anticipate what's going on, the first talk is by Arvind Narayanan, and that is from 12:15 to 1 p.m. Eastern. I know you all are joining from all over the world, so we're just keeping things in Eastern time because that's our hosting bias. But translate accordingly. So Arvind will be just starting in just a few minutes. Then at 1 p.m. Eastern, we have Kathy Pham speaking. Now this 45 minutes includes the introduction, a talk, and Q&A, which we'll get to in a minute. Then we're going to have a short break. And then from 2 p.m. Eastern to 2:45, we have Mahabali and Anna Mills speaking together. And then Kasia and I will give some sort of closing remarks, what to expect next, how to get in touch, that kind of thing at the end. Yay, we're really excited for our speakers. So I'm thrilled that Arvind Narayanan is our first speaker here today. I met Arvind in 2018, right after we started the Data Nutrition Project, when he gave the AI snake oil talk at MIT that ended up going somewhat viral and becoming the sort of the fodder for this wonderful book, AI Snake Oil, that he co-wrote with Sayash Kapoor, which is still my favorite AI book. So I'm so glad to have him with us. In addition to sort of that personal anecdote, I wanted to share that he is a professor of computer science at Princeton. He's also the director for the Center for Information Technology, also at Princeton. Um, the AI Snake Oil blog or Substack, in addition to the book, has a huge following. It's read by 60,000 researchers, policymakers, journalists, and AI enthusiasts. He's also previously co-authored widely used computer science textbooks, Bitcoin and cryptocurrency technologies, and fairness and machine learning. And was one of Time's inaugural list of 100 most influential people in AI. So he has a bunch of other awards, and I will stop there because it can get embarrassing if your intro gets too long. So thank you again, Arvind, for being with us today, and really looking forward to your talk. And I'll see you during the Q&A.
Thank you, Newman, for such a kind introduction. Hi, everybody, and hopefully you can see my slides. So my talk today is based on this essay that I co-wrote with Sayash Kapoor called AI as Normal Technology, in which we're also expanding in the form of our newsletter that Newman was kind enough to mention, and also a book project. What is this all about? The dominant narrative about what AI even is and how we should think about it goes something like this. Companies are building more and more powerful AI technology that's going to lead up to so-called AGI, or artificial general intelligence, and soon after that, superintelligence, which is going to have incomprehensibly vast, positive and negative effects. It can obviate the need for work, but by that same token, put people out of work. And superintelligence has potential existential risks for humanity, etc. You know the narrative. So the essay is about a different way of thinking about AI. It draws inspirations from the history of past general purpose technologies. It argues that so far, at least, contrary to the narrative, AI is following in those very same footsteps, and I'll explain what I mean by that. And we predict that this will continue to be so in the future. And more importantly, it's not so much a prediction as a prescription. We should treat AI as a normal technology, and we can ensure that it stays on that path. So the essay has four parts. One is about what timescales we should expect. The second is about AI and human labor. The third is about catastrophic risks. And the fourth is suggestions for policymakers. For today, I'm going to stick to the first two parts, and certainly happy to get more into those or the latter parts of the paper during the Q&A. There is a classic theory on how new technological innovations get adopted and diffused through society. And it goes like this. There are three stages. So if we look at a classic general purpose technology like electricity, the invention stage is, electromagnetic principles, AC and DC, that sort of thing. But people don't use electricity directly. They use electrical appliances. So that requires the second stage, innovation, these complementary technologies that are needed. And diffusion is how people learn to use things and how organizations learn to adapt to this new technology. So the work we've done primarily is to take this theory and adapt it and elaborate it in the context of AI. And we came up with a four-stage model. Excuse me. So the invention stage, that's what you really hear about in the news a lot, the increasing capabilities of these AI models. Today, primarily large language models, but not necessarily always the case in the past, might not be the case in the future. The second stage, and here I'm using the example of the use of AI in software engineering, but you can think of the use of AI in any industry. It's usually not people directly going to ChatGPT and asking it to do what they want it to do. More often, people use AI when it's integrated into the software products that they use every day, such as in the case of software engineering, people's code editors. And we're still in the very early stages of figuring out how to get that right. So there are these new tools like Claude Code. There are these new editors like like Cursor and AI plugins into existing code editors like VS Code. And people are even figuring out, are we going to be using graphical interfaces or text-based interfaces? So it kind of feels like, the early days of the PC in the 80s or 90s. The paradigms themselves are still being worked out. So once you have that, you get to the next stage, which is early adoption, where people are thinking about what their workflows are going to look like. So people are doing simple things like vibe coding, if you've heard about that. So using, AI prompts in order to code up simple apps without directly writing any code. However, to really realize the potential of AI, there are going to be deeper adaptations that are required in the way that businesses, enterprises are set up. It goes beyond the behavior of individuals. It requires collective action, changes to organizational structures and business models and so forth. Let me give you just one example for now. I'll have more examples later. Now, some people believe, I don't know if this is going to happen, but it's plausible, but many people are claiming that one day AI is going to be able to go beyond creating simple apps and create more complex pieces of enterprise software just based on us telling it, excuse me, what we want it to do. Suppose that happens one day. If that's the case, it will be silly for enterprise software to be developed and used in the same way that it is today. For these software companies to create one piece of software like Slack or whatever it is you might use at work or even Zoom, and then for every company, everybody in the world to have to uh, adopt the abstractions, the features that one company has decided work for everybody. Instead, we predict what software development will look like is software developers sitting down with each company or each team or whoever it is, figuring out what their particular requirements are and creating software, essentially customizing software to their particular needs because again, in this hypothetical future, it's going to be so easy to create software once we figure out exactly what it is we want out of software for a particular set of users. And so it's the figuring out what they want. That's going to be the hard part. That's what I mean by extreme personalization. And when you look at that kind of radical change that's needed in order to truly reap the capabilities, reap the benefits of the increase in capabilities of AI, hopefully it becomes clear that this is not some overnight thing. This requires changes to human behavior. It requires changes to organizations, which tend to unfold over a period of decades. So that's one of the fundamental insights of the paper. There's a lot more detail on this, but this is a simplified version. Okay, now I want to look at each of these stages. So first, I want to point out that when companies don't get the products right, when they are taking these increases in methods and capabilities and directly trying to put them into people's hands, things have not gone well. So you have to get this part right, and then you have to get each of the arrows in this chain right. So here's a good example of this. When ChatGPT came out, a lot of companies thought it's going to be easy to create these personal assistants, which are just simple wrappers on top of these large language models. But when they tried releasing such products, it did not go well. There have been some many notable failures where these are actually very capable products. This is kind of a hardware device that is controlled by voice, I believe, and you can order it to do things like, do shopping for you online. Sometimes it does a pretty good job, but sometimes what it does is, as you can see in this example here, it did um, order food for this person, but delivered it to the wrong address. And also you see here at the bottom, selected the highest step option, but whatever. So this is something fundamental about these large language models, right? They're very unreliable. So how do you create reliable software on top of this underlying unreliable technology? That is a grand research challenge. So taking these model capabilities and building useful products out of them is something that the industry is very gradually learning to do. And some of our research is also on this particular topic. It's not automatic. Now, we've seen this before with assistants like Siri and Alexa, but if Siri plays the wrong song 10% of the time, that's merely an annoyance. But if this new AI agent orders the wrong product for you or books your vacation to the wrong destination 10% of the time, that's a product that's going to be dead on arrival. And AI developers, I think, have been fooling themselves about it because they've been using model evaluation as a proxy to know if products are going to be useful. That's not working. One reason is what I just told you, which is the capability reliability gap. Capabilities can increase without reliability correspondingly increasing. Another big reason is what is called construct validity. So let me give an example of what that means. There has been a lot of hype about the fact that AI can pass the bar exam. Well, that would be amazing if the job of lawyers was to answer bar exam questions all day, right? So even though it's true that for human lawyers, the bar exam is a good test of how well they can perform in the real world, it turns out that for AI, using those same tests ends up not telling us very much about whether this is going to be a reliable product that lawyers can use to help them or replace some of their work in their day-to-day work. And there are many examples of this, but I want to show you one of them. There was a lot of hype about this company, Do Not Pay, that said they will pay $1 million to any attorney who would wear AirPods to argue a case in front of the Supreme Court and repeat what the robot lawyer is saying in their ear. Now, there was no robot lawyer. This thing was a publicity stunt. And the company must have known that because electronic devices are not even allowed in front of the Supreme Court. And they got slammed by the FTC, and you can read the complaint, and it's hilarious, all the misrepresentations they made. But my point here is that the reason so many people got snookered by this, the reason this was so compelling, is that many people have this, I think, misleading intuition that goes from these news headlines about AI passing the bar exam to believing that a robot lawyer might actually be on the cards. But it's absolutely not. When actual lawyers have tried to use AI for more complex things, they've very quickly run into the hallucination problem and many other difficulties. And so, in fact, in a paper co-authored with our colleague Peter Henderson, who is a JD PhD, what we found is that when you look at the many ways in which AI can be used in law, AI is pretty good at these kinds of simpler information processing applications that are often done by paralegals, but not so much at the things that require true creativity, reasoning, and judgment, or at least not yet. And because the former category is easier to test, a lot of the evaluation has focused on this kind of thing, and people have incorrectly generalized to, all of law and concluded that AI is going to be able to replace many kinds of legal functions. Okay, so that's on going from capabilities to products, and then from products to adoption. I want to emphasize that adoption happens at human speed. It doesn't matter how powerful the technology is. There was a paper that made the rounds last year with the headline finding that 40% of US adults are using generative AI. Again, this was a whole year ago, so that would have been incredible, except that 40% figure includes even someone who used ChatGPT once a week to write a limerick or something like that. When you drill down into those numbers and ask how much are people using AI, what are they using it for, what are they getting out of it, the numbers actually look very, very different. And our assessment is that when you really look at these numbers, it's not really any faster than the adoption of PCs or other classic digital technologies. So even though this is a pervasive narrative, we strongly disagree with the view that AI is being adopted at an unprecedented speed. It's being adopted at the normal speed at which most general purpose technologies get adopted. Okay, I'm going to skip a slide or two in the interest of time. And I've been mentioning that there are many changes to business models that might be required. And let me give one historical example. When electricity first became a thing, factory owners thought that they could reap great productivity benefits by replacing their big steam boilers with electrical generators. But that actually did little for them. The electrification of factories took many decades, and it took a while for people to figure out that the way to get the benefit of this is to reorganize the whole layout of factories around the logic of the assembly line, because electricity is a much more portable and much more kind of decentralizable source of power. And so that required changes in laying out the factories, how workers were trained, so many concomitant things. So those are the kinds of things we need to figure out with AI, and that's all going to take decades. So that's the first part of the paper. I'm going to take just 5 more minutes to tell you very briefly about the insights in the second part of the paper, and then I'm happy to get into Q&A. Now, again, there is the claim that as AI starts to automate more and more of the tasks that we do at work, especially cognitive tasks, it's going to leave so many of us without jobs. Maybe, but when we look at how economists look at the effect of automation on labor, a very different picture emerges. They use something called the task model to think about this. And the point of the task model is simple. I'll get to the picture on the right in a second. Jobs are bundles of tasks. Any particular job, yours, I'm sure, involves doing dozens of different kinds of tasks over the course of a day. And as AI capabilities advance, it's not going to be one specific day on which AI can now do all of those, 30 different tasks that you need to do at work. It's going to be one at a time. And typically what we've seen with technology is that as certain tasks get automated, the job description itself changes. What it means to do that job changes to focus on the things that AI can't yet do, and new tasks get created, often involving supervising these AI systems or automated systems or whatever it may be. And that's the reason why, even though there have been many fears, for example, again, in the case of law, going back 15 years to this headline that automation is making lawyers obsolete, what we have instead seen during that time is that the demand for lawyers has grown, not shrunk. So similarly, there have been classic predictions about AI's impact as well that everybody likes to laugh about now. But I'll give you that prediction, then I'll give you a kind of subtle takeaway from it that I haven't seen a lot of people making the connection. Okay, and that prediction is from Jeff Hinton, Nobel Prize winner, notable AI pioneer. A decade ago, he said, if you work as a radiologist, you're like the coyote that has not yet looked down and realizing that it's falling off a cliff. And he said this because, in his view, AI, excuse me, can read radiological scans, find tumors or whatever it is. And that's his view of what radiologists do at work all day. That turns out not to be the case. Again, there are dozens of different tasks that radiologists do. And in fact, radiologists have embraced AI. They're not shying away from it. And despite that, it has not replaced them. It has turned out to be a useful tool. So the thing that's often missed, though, is that this is not because there are some tasks that radiologists do that AI can't yet do. So why is it that AI has not replaced radiologists? My understanding, again, not a radiologist, but based on this as well as many other occupations, by the time you break down a job into a set of tasks so that you can even define it for AI to do, you've actually lost a lot of the nuance and complexity of what it means to perform that job. The hardest parts of any job end up being at the boundaries between different tasks or at the boundaries between different jobs. And so this whole approach that generates all these headlines of, okay, these are the tasks, AI can now do these tasks, and so people are going to lose their jobs. We think that is grossly oversimplified. It's never going to be an AI versus human comparison. It's always going to be AI versus AI plus human, because as you see in the case of the radiologist, people are generally going to be willing to make use of these tools when they help them do their jobs better. And so we have a very different approach to looking at the impact on jobs. And in short, while we think there is much to be concerned about, we think these apocalyptic predictions are just based on, very inadequate ways of thinking about the impact of tech on labor. And in general, I think we shouldn't be just listening to these AI experts, including me, or these economists, when predicting what's going to be the impact of AI on, law or radiology or really any particular occupation. While these kinds of experts do have something to contribute, primarily we should look to the domain experts themselves who work in any particular field, who actually have a much better understanding of what the limitations of AI are in their work, as a teacher or a healthcare worker or a social service worker. Again, any different domain that you consider. So that said, I do want to give you one tentative prediction. Again, this might not apply to every single occupation. Obviously, I'm making a broad generalization as a computer scientist, but I think this might be useful to keep in mind. We think it's quite plausible that in the future, most tasks across most jobs will actually be about controlling the AI tools that will actually do those tasks for us. And this might seem very radical, but I do want to point out that this kind of near total redefinition of what work means has actually happened before in the case of the Industrial Revolution. Before the Industrial Revolution, most labor was manual. That's what work even meant. And, the kind of thing we're doing now, this would not have been considered work, right? It would have seemed silly that people could just be talking and call that work. But today, most manual labor is automated. But, to take construction as an example, that did not eliminate the need for human labor. We have people operating those machines for safety and many other reasons. So we think that the same thing will happen with cognitive labor. So the actual, what we consider now cognitive labor, will be done by machines, and the role of humans will be the decision making around those AI tools, which often, surprisingly often, involve normative and moral considerations that I think we will not be and should not be comfortable delegating to these AI tools. Okay, so since I'm skipping the latter half of the paper, which gets into superintelligence, I did want to give you just one slide about that. So a lot of people will say, yeah, this is all true for now, but in the future, superintelligence will change the equation. We argue that that's not going to be the case because these radical claims depend on a fundamental misunderstanding of what human intelligence is. People like to look at chess, where today's chess playing programs are vastly better than the human world champion, and predict that the same thing will happen in every job category. But we think chess is actually a special case. There are three kinds of limits to human abilities. One is computational limits, obviously, as in the case of chess. Another is intrinsic limits. So AI over the last decade or so rapidly became better at writing, but then kind of tapered off at a level where it's kind of a mediocre writer. Why is that? Because unlike chess, it's not well defined what it means to be a really good writer. What works for one audience might not work for another audience. We know what it means to be a bad writer, and we can train AI not to be, not to make grammatical mistakes or any of the other obvious signs of bad writing. But beyond that, it's a matter of taste. That's what we mean by intrinsic limits. So it's not clear how to train AI to be superhuman. And finally, knowledge limits. People say that AI in the future is going to be a superhuman doctor, medical researcher, etc. The reason that's not going to be the case is that the limits of human doctors is not because of their computational limits. It's because of the limits of medical knowledge. And for AI to do better in terms of medical knowledge can only happen if AI is autonomously doing medical experiments on thousands of people. And obviously, we should not and will not allow AI to autonomously do medical experiments on thousands of people. So all of this together means that it's only in a very specific narrow set of tasks like chess and not most tasks involved in the economy where AI is going to be able to have superhuman performance. So the entire body of work predicated on some future superintelligence, we mostly reject. And we talk about this in the paper, and we also have some future writing coming up on this topic. So, in a word, I will say that in a sense, everything is going to change, AI being used as a tool for almost any cognitive task, and yet everything will mostly stay the same. We're not predicting massive job displacement, for instance, due to AI. And all of this will happen over a period of a few decades. There's a lot of change ahead, but I think we can approach it with a spirit of cautious optimism instead of panic. I'll stop here. Thank you very much.
Thank you so much, Arvind. That's a wonderful talk. And I know not only speaking for myself, but speaking for many people here, we could probably listen to you for much longer. And Kasha and I are going to come on now to ask you some questions. There's a whole bunch of questions that have come in to the Q&A. So maybe you could take a second to just kind of look at them, Arvind, in case anything really jumps out to you. And but we'll just kind of kick things off um,
Yeah, go for it.
and then take it from there. So there's one that came in quite early on. That's how do we integrate a focal point on environmental impact into the invention, innovation, diffusion process, similar to the priority of reliability, capability of the technology itself?
Yeah, definitely. I think it helps very much to get technically specific a little bit. So there's there's kind of this meme that using ChatGPT is extremely energy intensive. Now, that was true at the beginning, but things have improved a lot, and it's not that much more energy intensive than, let's say, Google search or really any of the other apps we use. However, and this is why it helps to be technically specific, it's very different whether you're asking a text query or asking it to generate an image or using the feature called deep research in many of these apps where it goes off and does some quote unquote thinking on its own for a while, which might take 15 or 20 minutes. So that's that many minutes of continually generating these text tokens, even if all those tokens are not shown to you. And so the true environmental impact between these different use cases can vary actually by several orders of magnitude, by like roughly 4 orders of magnitude. And yet that's not at all transparent to the user, right? So the two kinds of queries might seem very similar from our perspective. And because of the level of non-transparency of the design of these systems, it has not given us a good opportunity to develop intuitions about how much something is actually costing the environment. So it makes it hard for us to change our individual behavior. So that's one thing. And the second thing that's often, second distinction that's often missed in these discussions is that even though data centers are growing rapidly, AI data centers continue to be only at this point a small fraction of all of the data centers that are out there. And so the biggest consequence here is not, at least not yet, in terms of the global energy impact, but rather the local impact for those specific communities who are being hard hit by the demands of those data centers on the grid in that area or on the water supply and so forth. And so the two things that I think would be most important to change are to give consumers a better understanding, to change the product design so that consumers have a better understanding of how energy intensive various kinds of uses are. And for advocacy and activism, this is already it's changed a lot to focus on the local impacts as opposed to the global impacts.
Thank you, Arvind. Hopefully you can see me. My camera's working well. I'm going to try to combine. There's so many amazing questions. So thank you all for dropping questions. A reminder, you can upvote the ones that you definitely want to get answers to because we will not get to all of them. I'm going to grab two of the questions that are kind of related to each other and ask you them at the same time. And this is from, I think, Sharon and Joseph, two separate questions about kind of the impacts of AI adoption and forced AI adoption in the workplace. So these particular questions are focused around pressures within the workplace, either in educational settings or otherwise, where supervisors or managers seem to think that AI is ready to go, ready to be deployed, and maybe also pushing the deployment of these things, maybe before it feels like the folks on the ground are actually ready. So the question is the impact of this kind of forced adoption on integration and that pipeline you showed at the beginning, and also if you have any thoughts on that general trend and its impact in the workplace.
Yeah, definitely. That's a big issue. I think many of the decision makers who, first of all, don't have a great understanding of the day-to-day jobs that individual workers are doing, but also are falling for a lot of the AI hype, are forcing AI on people either as a tool or to replace people. I think the good news is that in many cases they're starting to recognize how short-sighted that approach is. A good example is chatbots. I mean, when ChatGPT came out, I mean, it's right there in the name, chatbot. You would think that customer service chatbots would be the first thing to get automated. And yet, when companies have tried doing that, they've run into a lot of trouble. There was that famous case where an Air Canada chatbot, I think, made up some non-existent policy to a customer, and that case actually went to all the way to the Supreme Court in Canada, and the court forced the company to pay up for what this chatbot had basically falsely promised. And so when they encounter these kinds of costs of hasty AI adoption, companies fortunately have been willing to rethink their hasty approach. And in many cases, companies have rehired customer service agents that they fired. But I think when workers collectively organize, both to exercise their power and to resist, as well as to present evidence about how limited these AI tools are, I think that can really change the behavior of the higher ups.
Thanks, Arvind. We have another anonymous question. What do you think are the strongest counter arguments to AI being normal technology? In other words, what, if anything, makes AI different from the historical examples you explore in your paper?
So just to clarify, AI as normal technology means that AI is not in every way like those technologies, right? And in one particular thing I want to emphasize, should have done so during the talk, I apologize. Uh, AI is having and is going to have unpredictable social effects. So these things around companionship, for instance, I would not have predicted that 2 years ago. The number of people who are going to come to rely on these things as companions for mental health support and all of the downsides that that is bringing. So that does not mean that it's not a counterexample to the AI as normal technology framework. In fact, the very reason we encourage viewing AI this way is to shift focus away from some of the superintelligence fears to actually bring attention to some of these very real and unpredictable social impacts that AI is having here and now, and I think will continue to have. Various kinds of destabilization, all of that is possible and is starting to happen. So that said, I think what will fundamentally cause us to maybe, start to discard this as a good way of thinking about AI is if it turns out in the future that AI is starting to do some of those classic things associated with superintelligence, such as be superhumanly powerful at persuading people to act against their own interests. And that becomes a challenge to keeping control over AI systems. This is not something we're seeing right now. A lot of the current research is being misinterpreted to claim that AI is very good at persuasion. But when you dig into the details of the paper, actually what they're saying is, oh, if people believe in conspiracy theories, these chatbots are very good at being patiently engaging in dialogue with those people and showing them the facts and so forth. That's all great news. And that's very different from saying if we try to keep control over these AI agents, they will scheme and trick us into doing things that are dangerous for humanity. Those types of things are not really supported by the evidence. But if that changes in the future, that's certainly a concern that would cause us to rethink certain things.
I'm just going to ask a quick follow-up to that before Akasha jumps in, which is related to another question that actually got a lot of upvotes, which is um, kind of reframing that, like, well, I'll paraphrase it. Rather than people being worried about things like job replacement, actually, this, as you just said, sort of futuristic possibility that AI develops the ability to recursively self-improve, and what that means in terms of like the possibility of an explosion, AGI, et cetera. So can you just like speak to, just to be super frank and direct with you, if you think that might happen or that could happen, when that could happen, and what technologically might be required if that were to happen.
So specifically, recursive self-improvement, superintelligence, those kinds of things. Is that what they're getting at? Yeah, recursive self-improvement could happen. In a way, it's been happening for a long time. A lot of AI development already involves the use of AI, and that makes AI development faster. So it's not one moment at which it suddenly takes off. There is a gradual acceleration in many ways. But for us, even if, regardless of how fast the improvement in AI capabilities goes, we think that the most important bottlenecks are all external to that. So regardless of how computationally powerful AI gets, again, when it comes to specific things like medical knowledge, the bottlenecks are very, very different. It's like, how fast can you do medical experiments? And people will say, oh, you can do simulations to figure everything out. I think, um, when you look at efforts to do scientific research using models and then transfer those insights over to real life situations, I think our kind of naive understanding of how well you can do that is not really backed up by how science works. So those are examples of where we think the bottlenecks are. And so what we're trying to do is separate two things that are typically bundled together. One is recursive self-improvement, and the other is superintelligence. Our key point is that one does not imply the other.
Great. Switching gears a little bit, the next most upvoted question here is about using AI in teaching and learning. So specifically, learning, helping folks learn critical thinking skills and problem solving skills. And as someone who's at Princeton, you've probably thought a lot about this, someone who's in an academic institution. How should current faculty and other educators approach learning about AI and their own classes? So both learning about AI and probably also using AI to learn other things in the classroom.
Yeah, definitely. So maybe let me start with the second half of that. So the use of AI, excuse me, in the classroom. So I encourage my students to use AI. I don't ban AI in my courses. That's not necessarily appropriate for every course, not for every discipline. But in my case, I have found that the best approach is to encourage its use. But of course, I teach them about the limitations of AI tools, and of course, they are responsible ultimately for their own work. And what it allows me to do is to push them harder because some of the drudgery can be handled by AI. However, when there are critical skills that students need to learn, then there's no alternative to that. Just because something can be automated doesn't mean that we don't have to learn that skill anymore. And so my favorite analogy for this is when I was a kid growing up in India, the education system hadn't really gotten the memo about the fact that calculators were a thing, and of course everybody still had to learn arithmetic. But even in my physics classes and calculus classes, we had to use these log tables to manually do very tedious calculations that were not helping us learn the principles of arithmetic or math or whatever. And when I look back at that, a lot of what happens, I think, in our current education is not the equivalent of teaching arithmetic, which is, of course, always going to be important, but the equivalent of forcing students to use log tables. So, what I try to look for as an educator is to really think about what am I making students do that are the analog of log tables. Log tables are, for folks who haven't heard about them, are tables that you use to slightly simplify the calculations of multiplying big numbers. But it still remains very tedious instead of using a calculator. In any case, so what am I asking students to do that is just drudgery? And one example is a simple example that I'd like to say is formatting citations. I'm comfortable using that to AI, leaving that to AI in my own scholarship, although I verify its work. And similarly, I'm comfortable with my students doing that as well, versus which aspects actually involve critical thinking. And in those cases, how can I ensure that they are not losing those skills? They're using AI to enhance those skills instead of using AI as a crutch.
Thanks. That's great. And just to mention to everybody, our third keynote today from Mahabali and Anna Mills will be focused on education as a case study for how some educators have been innovating and critically examining and using AI, and how others in other fields might even learn from what educators are doing. We have another question here from Alexandros Hardidis. Hi, Alexandros. Fantastic talk. And the second to last slide, where you talked about chess not being a model for most human tasks, you use the term taste. That is, most things in life, like the example of writing and book publication, end up being an issue of taste. Could you elaborate a bit more on this? Do you consider taste as an autonomous and independent judgment faculty of humans that AI does or cannot model?
Oh, sure. So my point was less about whether AI can have taste. It probably can. But rather that because everybody's tastes vary so much, it's not clear what it means even for AI to be, the best writer or whatever. And since AI companies have no like North Star to train against, which is very different from how they train chess playing engines, because you can figure out objectively what is a better versus a worse chess move, they can have AI play against itself and gradually improve. So many of these avenues of improving skills are not available in the case of writing compared to chess. And so the way that AI improves is kind of limited to mimicking human writing. And it mimics human writing really well. It can mimic human writing in different styles. Yes, it can do that. But ultimately, as long as the learning is limited to mimicking as opposed to kind of autonomous self-improvement, it seems to be bottlenecked by human writing ability, and it's not clear even conceptually what superhuman writing means, because I don't think there can exist one piece of writing which is like incredibly persuasive to everybody and is going to, change their minds and get them to change their political views, for instance, right? So that's a good way to think about it. So we can all think about ourselves. Do you think you will one day read a piece of writing, right, whether written by a person or a machine, that is going to suddenly cause you to question all your political beliefs, right? I would imagine the answer is no, and that is what I mean when I say how effective writing can be has an intrinsic limit. And that's the reason why superhuman writing is in many ways impossible in my view.
Maybe following up on the language and the writing, I think you're saying this in a global sense, all languages, but we know that not all of these machines are great at all languages. So we have a three-part question. The first is challenges associated with language representation, particularly in Spanish, for this particular question that came in from Lorena. And talking about AI training data, what can be done in the intersection of ethics, governance, and the broader lack of training data and data infrastructure in Latin and Hispanic geographies. The second part of that question is about a lack of comprehensive socioeconomic and demographic data on Latin and Hispanic populations globally, and how that impacts the equitable representation of AI development. And the third is, if you know of anybody working in these areas, could you give them a little hat tip or tell us who they are so that we can research them further?
Sure. I mean, it's the good news is that lots of people are working in this area. Feel free to shoot me an email. I can send. I mean, it's easy to, I think, find lots of research on this. But I'm happy to help there as well. But broadly speaking, I think a few types of activities can be very helpful. One is improving the data sets that go into the training of these models so that they're more multilingually representative. And here it's a big area where governments and nonprofits can play a role. And also, how can regulation incentivize or require companies who are making their products available in a certain country to do better at language performance in the languages used in that particular country. So that's one big area. And the second is data sets, such as I think the question mentioned, demographic data sets, et cetera. I think that's huge. So, in general, I think there's a bit of a bias towards thinking a lot about training data, but not about inference time data. Inference time is when you're asking the model to do something and it's looking up some data in order to provide an answer. Training has more or less kind of topped out. Yes, there's a lot of room to improve in terms of different languages and so forth, but I think a lot of future improvement in AI capabilities generally is going to be coming from how it behaves at inference time, how it gets better at finding the right data sets in order to answer your specific question, right? So there are tremendous opportunities for improvement. Even when data exists, it might not be digitized. Even if it's digitized, it might be behind some login wall, and in these AI models can't log into things. And even if it doesn't require a login, it might be too hard to find or not in the right format, etc. And this is low-hanging fruit. And by making existing data more easily accessible and understandable to these AI models so that they're available when people are asking it a question, you can tremendously improve the usefulness of those data sets.
Awesome. Well, I'm going to ask one question and then I'm going to give the last question to Kasha before we go to our next speaker, Kathy Pham. I just want to say there's so many brilliant questions and I'm so sorry that we're not going to get to all of them, but thanks all for being here and for sharing your questions. I'm actually going to take moderator's privilege and ask you a question that's not in the Q&A, which is if you had, this is a little bit science fiction, if you had the ability to transmit some piece of information about AI to the broadest possible audience, like everybody on Earth or everybody who's thinking about AI or using AI, if you had the ability to get a message to them, what would that message be?
The great thing about generative AI, as opposed to previous waves of AI like predictive AI being AI used in criminal justice, for instance, for risk prediction, and it's used for highly consequential things about people, jailing people and so forth. The great thing about generative AI is that it's a consumer technology. So when we want to learn more about generative AI, we can explore it for ourselves. And that is much more powerful than listening to someone like me talk. And I think, there's lots of capabilities, lots of downsides. The best way to learn about them is to just spend a few hours exploring the use cases that matter to you. That's much more helpful than any other way of learning about generative AI, in my view.
Thanks so much. Kasha, over to you for the last question.
Final question. I'm going to grab one from Rachel. It's been upvoted a bunch about your optimism, which I think is palpable through the screen. And from a lot of the questions, I think people are feeling not so optimistic or maybe even a little bit scared. And so they want to know, why are you so optimistic? And can you please share in why you're so optimistic and whether or not we should also feel optimistic, especially in the face of a bunch of bad actors and a bunch of bad stories that we hear about AI in the news right now?
Yeah, I would say I'm cautiously optimistic. And that doesn't mean that there aren't challenges ahead or challenges here right now. There are, for sure. Yes, there's a lot of bad things happening with AI. But I think the lesson of AI as normal technology to me is that when we look at these incredibly powerful technologies in the past, we did manage to navigate our way through those challenging times. Again, which is not to minimize the harms. When we look at the Industrial Revolution, for instance, there were the first several decades were awful for workers, right? It led to a mass migration of workers from rural areas to the cities where they lived in cramped tenements. Safety was bad, worker rights were bad, but ultimately it did give rise to what we consider to be the modern labor movement, and that led to a lot of regulation, changes in standards, and so forth. And my hope is that by looking to history, we can confront those difficulties that we're facing, and maybe have less than a several decade period of awfulness in order to figure out how to regulate this technology, how to best integrate this technology, and get to a future where we can derive the benefits of automation without necessarily paying as high a price as we often did. Even recently with social media, right? After knowing that there are many challenges in terms of kids and mental health, it's taken such a long time for policymakers to get serious about it. And a lot of the reason for what we do, which includes a lot of talking to policymakers, is to be a little bit quicker about that process.
That's a great note to end on, and also anticipates Kathy Pham, who will be coming up next, looking a little bit more at AI and history. Um, One of the sad things about a webinar is you don't get a round of applause from a massive audience. So just know that, I mean, folks in the background, you're welcome to clap to yourselves. But Arvind, just know that I think the questions indicate what an amazing appetite there is for your work. Thank you so much for being here. And with that, I'm going to turn it over to Kasha to introduce our next speaker, Kathy Pham.
Thank you. This has been really fun.
Thanks, Arvind.
Thank you, Arvind.